Okay, so when you get one of these ACA problems, the first thing you should do before you answer any part of it is to draw a picture with the information we're given. So I'm going to draw a little eye here, and then I'll draw a nose so I know that this is a right eye. And then I'm going to draw a line going straight out. This will be our ortho line. And it doesn't say anywhere in the question if the patient has a distance lateral phoria, so we can just assume that this patient is ortho at distance. Okay, and then next we should take their PD, which is 66, and divide it by 1/10 of the working distance. So 66 divided by 3.3 equals 20. Okay, so what does this 20 mean? Um, that means that a patient who has no phoria and has a PD of 66 working at a distance of 33 centimeters will converge 20 prism diopters from ortho. Okay, so I'll say that again. A patient who has no phorias has a PD of 66. If we start at ortho and then we have them look at a target that's 33 centimeters away, they'll converge 20 prism diopters, so 20 PD, and then I'll draw a line here. Okay. Um, so this number actually happens to be our convergence demand. So we'll call that 20 PD is our convergence demand. Okay. But our patient does not converge 20 prism diopters. They converge only 15, which means they stop 5 short. So from ortho, they converge 15 and they land right about here. And so we know that this total distance is 20, but they stop 5 short. So this distance is 5. Okay. What is their near lateral phoria? So we know they're stopping 5 prism diopters short of where they're supposed to. And they're landing 5 prism diopters further away from the nose. Okay, so a normal person would go this far. Oh, sorry. A normal person would end this far, but this patient ended here, which is further from the nose. If you're further from the nose, then your eye is out, which means you're exo. So this patient would be 5XP, 5XO for you. Is it normal? So the normal near lateral phorias is 3XP plus minus 3. So anywhere between ortho and 6XP is normal. So yes, this is normal. What is their compensating fusional vergence? So the easiest way to remember it for me is that we measure exophoria with the base in prism, right? So if you're doing cover test in real life and you see a patient's eye moving in, which means it was out, you know they're exo, which means you neutralize it with base in prism using your prism bar. So you measure XP with base in and you compensate for it with base out. So it's just the opposite. Okay, so if you hypothetically had an ESO patient, you neutralize their phoria with base out prism, but they compensate for their esophoria with base in prism. Okay, but our patient is exo, which means we measure exo with base in prism, but we compensate for it with base out prism. Okay, I'm sorry if that was confusing. Okay, so then next, with a +1, what does their phoria become? Okay, so we have their ACA. Their ACA is 5 to 1. So what does this mean? It means that for every 1 diopter of refractive change, they converge or diverge 5 prism diopters. Okay, so how do we figure out whether they converge or diverge? When we add plus, adding plus relaxes your accommodation. So relax, which makes your eyes diverge. And then if we add minus, we stimulate accommodation, and then we make the eyes converge. Okay, so back to the question, the patient, we add a +1 to them. Uh, so we know they're going to relax their accommodation. We know they're going to diverge. Um, and it's one diopter. So for every one diopter of refractive change, they're going to converge or diverge 5 prism diopters. So this patient will diverge 5 prism diopters. So remember, they're normally, without correction, they're about here, right? They're 15 short of the 20 that they're supposed to be. This one, once we add the +1, they diverge 5 prism diopters further. Okay, so we already know they were 5 short, and now they diverged another 5. So the total amount of distance they're away from the 20 prism diopters that they're supposed to be is now 10. Okay, so they're 10 prism diopters further away from the nose um, than they're supposed to be, which means this patient has become 10 XP. Okay, and then now we add a -1 lens. So if we add minus lenses, we're stimulating accommodation and we're converging. So this time we know they're going to converge from where they were. We're going to ignore the red lines. I'm just going to erase them. Sorry, this is very unprofessional. Just ignore me. Okay. So we're not putting the -1 on top of the +1. So we're starting again at this line right here where they're 5 short of the 20 prism diopters they're supposed to be. And this time they're converging, which means their eyes are moving towards the nose. They're converging 5 prism diopters, okay? So they stopped here, they converged 5 more, and they landed right here at 20 prism diopters. I hope that makes sense. So they originally were 5 short, and they converged an additional 5 because we put the minus glasses in front of them, and they ended up at 20, which means they're now right on the line. They're not any further or closer to the nose from that line. So in this case, the patient is ortho.